Hello, my name is Victor Terlaky. In this talk, I will be giving an activity update for the Energy Geosciences group at the Northwest Texas Geological Survey. Our staff currently consists of two people, myself, the senior energy geologist, as well as energy geologist Jonathan Rochelot. Our manager, Kathy Feast, retired in October after 8.5 years of service, and we would like to thank her for dedication and hard work while she was at the NTGS. Our project work for the past year consisted of 5 separate projects. Number 1 is the Shale Basin Evolution in the Central Northwest Territories. This is our longest running project right now. Number 2 is the Liard Basin Geothermal Project. Associated with that is number 3, our Phanerozoic Thermal Evolution in the Southern Northwest Territories. Number 4, the Yellowknife Conmine Geothermal Project. And finally, number 5, the Arctic Offshore Resource Assessment. In this presentation, I will be talking about each one of these presentations in more detail. The first project that I would like to introduce is the Shale Basin Evolution in the Northwest Territories. This is our longest running project to date. As a little background, the oil in the Norman Wells oil pool was sourced from the Canal Formation. The Canal Formation and the Bluefish Member of the Herring Formation are both Devonian black shales, which have become a research interest to industry and NTGS since about 2010, with their focus on the unconventional resource. 627.5 million in work-day commitments for exploration licenses were granted from 2011 to 2014, with industry activity between 2012 and 2014, including 7 wells drilled by ConocoPhillips, MGM, and Husky. This resulted in 2015 in an NEB and NTGS joint publication resource assessment with estimates of about 190 billion barrels of oil in place. The objectives of this project are to use well, field, and seismic data to characterize a map and model Devonian plays in the Mackenzie Fairway. Our aim is to determine chronostratigraphic relationships between the various rock units, to develop a sequenced stratigraphic framework, do geophysical interpretation, map thermal maturity trends, map hydrocarbon potential, do basin modeling, as well as at the end come up with a refined resource estimation. The Shale Basin Evolution is a multi-year project which commenced in 2014. We anticipate it wrapping up in 2021. The field locations include 11 field sites, which we visited across 3 field seasons in 2016, 2018, and 2019. We also investigated 14 wells across 2 seasons in 2014 and 2018. This is also a collaborative research project. Our collaborators at the University of Alberta include Dr. Murray Gingras, who is the scientific lead, and his graduate students. Myla Grange is a PhD candidate who is set to finish her thesis next year. She also is giving a presentation in this symposium, and I encourage you to check out her presentation. Brett Harris and Sarah Biddle are both MSc candidates who just successfully defended their thesis 2 months ago, so I would like to congratulate them on the successful defense. Lastly, we had Nicole Atienza, who finished a PhD thesis on this topic. This is a large project that employs various methods and techniques so we can come up with the final conclusions. We investigate lithogeochemistry and mineralogy through XRD, petrography, XRF, and ICP-MS methods, organic geochemistry through source rock analysis and viscerite reflectance. We also investigate chrono and biostratigraphic relationships through stable isotopes and rhenium-osmium and uranium-lead dating, as well as conodon dating. Porosity is estimated through scanning electron microscopy and ichnology. We also investigated sedimentology and stratigraphy, both from the field and from core. We also did geophysics through seismic analysis and interpretation. And lastly, the basin modeling is done through a software called ZetaWare. Since this is a multi-year project that has been ongoing for about 6 years, our deliverables list is fairly extensive. To date, we have produced 22 conference presentations, including 2 for the symposium. One I've already mentioned is Maya's presentation on her work and update for this past year, as well as Jonathan Rochelot's presentation on his basin modeling efforts. I encourage everybody to check out both presentations. We've also produced 2 open files, 7 open reports, 3 of which came out this year. I would like to highlight these 3. Number 1 is the 2016 field report. Number 2 is the seismic interpretation, which is a contractor's report made by Alan Adrian. Number 3 is the Horn River Group Sequence Stratigraphic Framework Part 2 by our University of Alberta collaborators. We have also produced 1 place summary, and of course 1 bachelor's and 2 master's theses. The future work is really a wrap-up happening in the next year. There's still several open reports in the pipeline. One is the 2018 field report, and also a revised ISOPAC and cross-section map report. As a final wrap-up, we are going to publish several academic journal articles, and of course, we're going to give conference presentations at the CSPG Geo Convention and the Yellowknife Forum. The second project I would like to talk to you about today is the Liard Basin Geothermal Project. As a background, the government of Northwest Territories has a mandate to reduce the carbon footprint of the Northwest Territories, as well as a goal to reduce the reliance of communities on diesel energy. To this effect, we are looking at renewable energy sources in the Northwest Territories. The Southwest and Northwest Territories, particularly the Liard Basin, has been shown to have elevated geothermal gradients. This has been shown by workers from the University of Alberta and the GSC. Now in 2019, the NTGS started a collaborative project with the Department of Infrastructure's Energy Division to assess the geothermal potential of the Liard area. The overarching objective of the NTGS for this project is to provide the geoscience framework to evaluate the alternative energy potential and solutions of the Devonian carbonates of the Nahanni Formation as a high-temperature geothermal source. To do this, we aim to do reservoir characterization studies, which will assess the areal extent, the thickness, lithology, mineralogy, porosity, permeability, as well as the formation temperature of these rocks. As a first step in this project, this past year we investigated 8 wells from the Liard area. These wells were described and photographed at the GSC Calgary. As well as lab analysis on these wells included SEM petrography, thin section analysis, XRD mineralogy, as well as core analysis for permeability and porosity for a number of these wells. The number of analyses for each well is highlighted in the table below. Future work for this project includes the 2021 field season, where we propose to describe and sample 6 sites in the Liard area to add samples to our collection and our analytical suite. Then we will produce reports detailing the analytical data and interpretations for both the well and the field samples. And of course, this is very much a project that is a work in progress. The third project I would like to talk to you about today is the Phanerozoic thermal evolution in the South and Northwest Territories. Now, this project is very much an extension and an offshoot of the Liard Basin Geothermal Project, as it is associated with the thermal evolution of the basin. This is a University of Calgary and NTGS collaborative project, which was started just recently this year. It aims to investigate and quantify the thermal evolution of the Phanerozoic sedimentary rocks across the Southern Northwest Territories, which will aid in determining the thermal history and heat potential of the proposed geothermal project areas. Our collaborators in this project are from the University of Calgary, Dr. Abel Enkelman as the scientific lead, and we have a new PhD candidate starting in January. Her name is Thais Fontes Pinto. The work to date on this project includes the sampling of core and outcrops around the north arm of Great Slave Lake. The map on the right that shows the location of the sample sites is from the poster submitted to this symposium by Dr. Enkelman. I highly encourage you to check out that poster for more details on this project. For this work, we chose to sample basement rock and overlying sediment cover pairs that will inform the thermal history of the strata, both below and above the subcambrian unconformity, to allow comparison of their thermal histories. Analysis include apatite and zircon, uranium, thorium, samarium, helium analysis, fission track analysis, and zircon uranium lead age dating. For future work, we are proposing a 2021 field season where we would like to sample 4 sites with Cretaceous outcrops to the northwest and northeast of Fort Simpson. Once again, this is a fairly new project, so very much a work in progress. The fourth project I would like to talk to you about today is the Yellowknife Con Mine geothermal project. The Con Mine is a decommissioned deep gold mine within the Yellowknife city limits. It has previously been proposed as a candidate for geothermal heat extraction for regional heating because it is close to the city of Yellowknife. The heat demand and energy prices of Yellowknife are high, and also because the high rock temperatures in a deep mine. So these factors would make it potentially a good candidate for regional heating. This study aims to provide a revised estimate of the geothermal potential of the mine based on improved analytical and numerical approaches. This is also a collaborative research project. Our collaborators at the Institut National de Recherche Scientifique, or INRS, in Quebec City include Dr. Jasmine Raymond and his master student, Dan Nagoya. This is also a really new project for this year, so we have only had one field season for sampling. This summer, the NTGS sampled surface as well as core from the Con Mine property and sent these rock samples to our collaborators at the INRS. These samples are being analyzed for thermal conductivity, diffusivity, heat capacity, density, permeability, and porosity by the INRS team. Future work will also include mineralogical analysis of these rock samples. For preliminary results, please see Dan's talk that he submitted for this symposium to get more details on this project work. And of course, because this is a very new project still, this is very much a work in progress. The last project I would like to talk to you about is the Arctic Offshore Resource Assessment. The government of Northwest Territories is in negotiation with the federal government about the offshore oil and gas rights and revenue schemes. Kathy Fries from the NTGS has worked as a subject matter expert to review the GSC's methods and results in their offshore qualitative resource assessment, which is a part of the negotiation process. Currently, her recommendations have been submitted to government, and as such, the project status is complete. As has been apparent throughout this presentation, most of our projects are collaborative efforts between either university collaborators or other government agencies. So I would like to recognize, acknowledge, and thank everybody who has been involved in our projects and really made them possible. Without you, these projects would grind to a halt and would not finish successfully. So I'd like to recognize our collaborators at the University of Alberta, at the University of Calgary, at the INRS, the Geological Survey of Canada, and the GNWT Department of Infrastructure. Thank you all. Lastly, thank you very much for checking out my talk. If you have any questions about any of these topics or any other matters, feel free to contact me at my government email. Thanks again. Bye.